Right. So if I go through my plan for today's session, so I'll be starting briefly work on like what data analytics means. And we used to use, different technical terms starting from artificial intelligence, machine learning, deep learning, data analytics, and so on. So let me briefly give you like how these are interrelated each other. And then let me talk about what data analytics in transportation and logistics and what kind of applications we will see, especially by going through, related work. And then I would like to go to the tools and technologies available in the data analytics area, which could be, incorporated in your day-to-day decisions as well. If I into data analytics. And then I will direct some of the research publications, those who are interested in working on research problems, the journals available, as well as the data sets, the techniques that used in the research work. Right. So having said that, let's start. Now, my first one is about the transportation and logistics, which means basically when you have an organization, you focus on, giving improved services to the industry, the customers, the customer satisfaction, and also like you have to improve the inter processes. Now, when it comes to, use of technology, as very correctly said in the start of the presentation, Dr. Sampath, regarding what has happened for us, in the pandemic area. So we had this interaction with the physical means. We have to minimize that. Now, what helped us to move in the operations is use of technology, right? So, and I think almost all of us now witness that the increases of technology available that actually, use in our decision making as well. Now, in this graph, what we see is like, I have taken this from the Google Trends, where like how people actually use this terminology in the search. So, I mean, right, the current situation is like most of the time we make the decision based on the data, and you can see by August 2022, you can see the term machine learning is the highest ranking or highest search term compared to the other things. We mentioned about the artificial intelligence, we mentioned of big data, data analytics, and so on. And you can also see that the term data analytics actually getting popular after 2015. And the data mining was quite popular in the beginning, but now, compared to that, it's actually a little bit of degrading. So which I think this graph will give you an indication how important to know the data analytics and related technology, especially when it comes to making intelligent decisions. Right. Now, so what is data analytics? Right? Basically, we are going to look the data, and especially we are going to make decisions based on the data available. So which means we are going to use the data to make useful information, and which help us to improve the productivity and also business gain. I mean, especially when you have a competition, like to gain the competitive edge. Now it's a must that you use data analytics. Now, having said that, now let me go through like how the other terms are interrelated to each other. So artificial intelligence is the term that we have seen for some time now, and that starts with the giving the computers to the intelligence, where artificial intelligence to make decisions. But remember, as experts, we should know that these technologies we use to support. So basically, artificial intelligence techniques were used as decision support systems, where there will be an expert which can use to make own judgment based on what these technology suggest. So inside the artificial intelligence, we have the subfield called machine learning. basically in machine learning, we focus on algorithm development and we focus on data-driven modeling, which means the decisions actually come out from the data. So the input to machine learning model, we say, it will be the data, and then you will get the, inside the pattern, the structure will be the output. Usually in computing, normally we will say, okay, decision structure will come out from, machine learning algorithm. And under that, the deep learning got popular after some time with the invent of, with the computing power, and also again, rethinking how the neural networks, so the deep learning techniques, actually we focus on having large number of hidden layers within the neural network. So as you can see, analytics and the data science resides on actually overlap in these areas. Right. Then the next question is, what kind of a background you should have to work in this particular field? Now, I know that most of you have the expertise, the domain expertise and logistics and transportation area, where you have to, if you have the appropriate math and stat background, so that's what we do, the traditional, the research and traditional, decision making. Whereas if you want to make a smart decision, that you need to have the computing background as well, right? In computing background, with the computer background and with the math knowledge, we have this machine learning where we focus more on developing algorithm. But when it comes to data science field, it will come together with the domain expert. So that's why we talk about the data analytics as well as data science a lot in the industry. Now, if you look at, data science as well as data analytics skills, if you focus more on, data analytics skill that you need to work is basically comes with how do you handle the data? How do you visualize? So the more focus is going on, look at what data tells us, right? So visualization tools use comfortable with the latest ones will be very helpful if you're on to, data analytics, right? So, and also how do you manage your data? But at the same time, data science part will be more focused on the algorithm development in computer science, machine learning, software development, and so on. But both actually share some of the things. For example, the problem solving, right? Basic statistics actually, used in both data science as well as data analytics skills. Now that we have got some idea on, what data analytics means and what kind of skills set that we need to improve in case if you want to incorporate, data analytics in your area. Right. Now let's look at, different types of data analytics, problems. Now, when you have data, the simple things would be you start with simple statistics, you look at whatever the existing data. So this is getting descriptive statistics, getting mean, skewness, mode, and so on, and also getting histograms. So basically the question that we pose there is, okay, what happened? So what happened during, last 3 years? What happens during last quarter, and so on. But if you want to get smarter, right, now when things go wrong, for example, we want to know why it happens, right? The pandemic area actually heavily, influence our different sectors to operate in a different way. So we had some issue in the beginning during the start of the pandemic, and we, gradually, adjust or adapt to it. Right? So the data should tell us these information that should be somewhere. So we can identify this. You can look at, we call diagnostics analytics, where you can look at why this is happening. Right? But this is not the interesting one. We want to predict the future. Right? What will happen now? For example, if it is a transportation problem, how many days it will take if, for example, in this weather condition, how many days it will take, if this is the what will happen during the external conditions. So that means we should be able to predict as well the forecast in the future, right? So especially in logistics area, if you want to think about the forecasting, so that will be another interesting where you need to predict it. And if you want to go more on this, then it should suggest that the data should suggest that what to do. I mean, like it might suggest us what to do with this. So the question is how to make it happen, right? So that's about the future. And the technologies involved in, if you can see, the first one is data exploration. Basically, you look at the data, you are telling a story based on the data you have. Whereas then when you want to look for the future, then you have to have the science of it, you have to use data science skills. But if you want to go for more improved predictions, if you want to go more on getting suggestions from the data itself, then yes, of course, you have to go inside the algorithms and you have to go for machine learning. So as you can see, the complexity of the problem will increase when you're going from descriptive to prescriptive analytics. And the value of the organization will get also increases. So that means if you're on to only descriptive analytics, I think it's a high time you plan to go from descriptive to prescriptive analytics, because they are the one you have to use to get the competitive edge, especially when you have a challenging environment. Right. Now that we have looked at the different types of data analytics area, right? As you can see, these 4 different types, you can see the complexity increases. At the same time, the value added, the contribution also increases. So most of us, I'm not saying that everybody doing this. I know some of the companies, they are using the cutting edge technologies. They were incorporating big data analytics. They were using deep neural networks. They are having data scientists to analyze their data and so on. So most of the work is going towards this, but majority we are still here. We use Excel spreadsheet based analytics. So I'm not criticizing that. You can do actually a great job with that, but now things have changed over the time, and it's a high time that if you still work with the spreadsheets, okay, you have to move forward. Now, having said that, let's look at what are the stages. These are very similar compared to the other stages as well, but you need to look at the data analytics area. So you start with the data acquisition, and interestingly, it's not that the data that you collect, right? Remember this, because the data is everywhere now. Now, for example, you can collect data, you can give a survey, you can manually collect the data. But then if you have like GPS installed in your transportation system, that will actually collect it. And if your workers use mobile phones, then of course there's another set is the data is you can use to make decision. And your customers express their views on your products, right? So that is another source, which means during the first stage, you can acquire data from multiple sources. Now, then the second one will be the data will be not in good quality, and data sometimes not important for the problem that you at hand. So you have to extract information and you have to clean. Sometimes you have to fill missing values. Sometimes you have to remove some of the data points because they are garbed and so on. Now, the third one is you have to aggregate. When you say aggregate the data, as I told you earlier, the data coming from multiple sources, they come from different formats, different structures. Now, for example, if you use social media data, we have free format. So that means you have to put it to a proper format. So we have to talk about the integration, aggregation, as well as the representation. Then comes the, modeling aspect of it. Like you predict, for example, you can predict the time, you can predict whether particular customer, whether he buy the product or not. You can predict the stock levels by end of this month and so on. And you can forecast your sales, for example, right? And that means the modeling techniques will give you different patterns. And last one is very important. Yes, you should know how to relate it to your decisions, right? You can actually find any random pattern from the data. So that is one of the problems in the beginning. You can find random patterns in data, but they are not important, especially if you are in industry, and if you want to make a competitive edge, and if you want to increase profits. So you should know how to interpret your data and get smarter decisions, right? So especially these days, we focus on getting smarter decision based on the data. Okay, now I think we have a look at the pipeline, and let me show the more complex one. I'm not going to go into details, but this actually gives you a whole picture, starting from capturing the data and also the processing, the cleaning, the storing, and also analyzing, and finally using this. And there are different technologies also we have used. I'll come to that point. Those technologies later on, but for the time being, this is not a very simple flow or workflow, we call it in data analytics. So it is very complex, and it's actually depend on your problem, right? So depend on what kind of data you use, you have to use different techniques. Okay, so having said that, let's move on to particularly what techniques actually people use in transportation and logistics area. Okay, right. Now, as I told you earlier, the data coming from multiple sources now is, if you get transportation, for example, many times we see the loop detectors where we will, get data out of it. And then you can use the data, you can calculate the moving speeds and so on. So whatever the measurements that you want to take from this, and you can have the indicators. Now, apart from that, the second, most used one is the GPS, right? And we have applications which can actually record this information. You can track your vehicles, right? You know where your vehicles are right now, right? And then you can monitor traffic, right? We can real-time monitor where the traffic congestions are, right? And then you can combine it with the mobile phone data, because in mobile also there are a lot of sensors are there. So those sensors could be used to make smarter decisions. Plus CCTVs, the camera is all around. You have a dashboard cam, and also like the CCTV cameras placed in your organization, and also the around the city or warehouse and so on. So where you have the access for this data, again, can be used to improve your decision making. Next one is very interesting. Now people are offering data for free. Now commercial ones, for example, Google traffic, where you can actually access to some of the data available. And likewise, there are other services, TomTom, Intrix, Waze, and here.com, here traffic data. So sometimes you have to partially pay, but the data is available. That is the interesting part. So which can use to analyze data in multiple countries. Sometimes you can perform the same analytics with, you can compare your performance with the other international organizations, right? Not only that, sometimes the weather information, again, that can be used for as a data source. So now we can see there are multiple data sources are available. And okay, so what kind of advantages we can take? So here are the advantages I have taken from, I told you, like, I'm not an expert in this, but I have seen, what work, done in here. So you can add more to this one. So you can look at the use of road infrastructure, especially, when we have the new road development projects, you foresee, okay, people will use. But once you construct, okay, sometimes people not use that facility. So that's why I said, so we should be able to make the prediction from by, incorporating historical data. So we sometimes use to say the history repeats, which means that, so sometimes the historical data can be used to make a smarter decision for the future. Again, for the reduce the conjections, and you can find out, what is the root cause for this, which actually can lead to reduction of this. Decrease traffic fatalities, especially, sometimes depend on, the traffic. Now, for example, when I, for example, want to go from the faculty to Candid, there are multiple paths I can take. So if my prime concern is the safety, then I might not get the route given by, let's say, Google Map, right? So you can suggest, people take, let's say, those who wants to go for different one, they can go a bit far, right? Irrespective of the time, that actually give you safer drive or safer route than the what is suggested. And I have an example for that. I'll come to that point. We can improve the fuel consumption. I know what has happened to a couple of months back with the fuel crisis what we had. So sometimes what our tools suggest is not the best route if you focus on the fuel consumption aspect, right? Most of the time our tools are focused on the shortest time, right, or the shortest distance and so on. And again, you can use it for decrease construction worker injuries, especially work with the during daytime. So there could be some issues. So these actually comes from the applications. Right. Now, if you look at the applications available, there are many applications I can see and people are currently working on, right? Starting from autonomous driving, which is very exciting, which is, I do not think in our Sri Lankan context, we do not have the proper infrastructure for that, but still we can work on it. And then vehicle identification, still we use manual systems, but then we have automated systems. We are now using a video stream, we can capture the type of vehicle. And not only that, we can identify the flow, the traffic flow, the direction, whatever the information that you can extract from the simply capturing a video, right? So you can minimize the manual labor. Another one is the driver behaviors. Now, for example, use of mobile phone could be, detect from, video stream. Again, I will have an example for that. Then pedestrians, automatically detecting pedestrians and, sometimes their emotional states, which if you can predict that, that can be used to minimize, the road accidents. So you can see there are array of application we can think of, and I know definitely some of you actually working on these application areas. My point here that you can actually work progressively or efficiently using the technologies that develop in data analytics area. Right. Okay, let me give you some couple of applications where people actually publish with the data. So for example, this data set actually about, extracting driver behavior from the videos. They have recorded video clips around 6,000. One is with the dashboard, and then the other one is the faces. The primary aim for this work is they want to detect, how they use the mobile. That means the start of the use of the mobile phone, and also like, the making calls and what will happen, right? So the idea there is basically simple classification problem, automatically identify driver behavior in different types, like whether he's interacting with the phone, whether the person is talking on the phone, or whether there's no interaction with the phone as well, right? And you can see they were looking at very interesting results, especially the technology they have used with the 3D convolution, networks, which is again going with the deep learning techniques, which is very popular nowadays, right? So when they work on the videos, actually they were focusing on, clipping the video where they want to extract the important features out of it, which is, I think, very important. Sometimes you also want to, look at the behavior of your employees, especially in the transportation area, right? The second one I would like to, share is an application based on the GPS navigation data, especially, drivers' choice on different routes. Now, those who use Google Maps, for example, sometimes when you want to go to a particular destination, it'll give you, different routes. And we normally depend on our choice. We make a decision. So that is very important to know. And sometimes we want to know why particular drive actually made that choice. Now, for example, in these two graphs actually the data coming from the Seoul, Korea, and what they show is they will also give you a path, and at the same time, they will give you a path based on, for example, the safety, which is very interesting. I think it's very important again to available this kind of choice, because right now the traditional application, they don't offer a service like this, right? Another one is, as I said, like identifying the signals, automating processes. Now, in this particular work, actually, they were working on identifying the radio traffic signals, and especially they were looking at the problems they will have when you use video stream data. Now, especially sometimes the detection, you will have false positives, like they are not really the traffic signals. The first one is you identify the traffic signals that we will call the boundary of this. And at the same time, then you need to know like what it means, whether it's to go or move forward, or it's a stop, to try to understand the action to be performed, which can lead later on the automation of these systems, which I think will happen in some of the developed countries. Right. Another interesting work, especially looking at the traffic data, they were comparing the similarity of the city's traffic data. So in this particular work, actually, they were working on, identifying similar groupings in the data. And they were also noticed here that these demographies are related, or they are close to each other, right? Again, very interesting to see how the traffic, data is actually influenced on the city's traffic. So in this particular set, actually, they were looking at, about 6 months data, about 45 countries they have analyzed. And the work is based on the time series clustering, because the time it's involved in this So the time series clustering algorithms were used in this work. Right, now having seen these some applications, next I would like to present you some of the tools and technologies which use in this area, and at the same time some of which you can also incorporate in your work as well. Now, the main things that I'm going to highlight here is the machine learning techniques. We already discussed why machine learning is important, especially if you want to make predictions and foresee the future, you have to go for machine learning. And the deep learning particularly is the subfield in machine learning, especially when you work with images and videos. Yes, definitely you have to go with deep learning networks, who are again quite popular. Last one is the big data. If you get real-time data, like for example, let's say you have a real-time traffic data, which will be huge, and not a single computer can handle the amount of data that you are getting. So of course, then you have to go for big data analytics. Right, now if I show you the whole stack of technologies available in this particular area, some of the tools available you to work from data acquisition to getting insight. But then again, during that you have to focus on handling data. Again, you can see there are a lot of technologies are used. For example, in databases we have now non-relational databases. So these you can see it here. And then you have to make decision whether you are going to have on-premise data, that means you are going to physically store, or whether you are going to have your data on cloud, because things were changing over the time. Now, instead of having a physical infrastructure, now many now prefer to have everything in the cloud. The next one is the development, training, and evaluation of your models. For, let's say, you want to classify your data. You want to identify what will happen in the future. So model development, again, could be in two places. It could be in your own premises or in the cloud. And the technologies were used, especially Python, for example, is quite popular. That is the #1 programming language today for anything, but most popular in the data analytics area, as well as Jupyter notebooks, which we will write everything as a notebook. And then we have technology to convert into a web app, right? So you can do the experiment at the same time. Within a couple of minutes, you can put into a web application. And that actually normally we will nowadays actually work with the students as well, which is not that difficult if you have like at least some programming background. These other frameworks, especially for deep neural networks, PyTorch, Keras. So these are very popular libraries available for deep learning as well. Now, other than that, there are some other things are also important, especially Dockers, like these different software. We have different versioning. So you have to have, virtual environments. Now for that, these technologies are again important. And to handle everything, that means starting from the handling the flow of this, and also the deploying this in maybe as a mobile platform, as a web application. Again, you have to have a set of technologies are there. So under that, you have to have a way of monitoring your data, have a way of testing, bug reporting, issues handling. For that, various technologies are actually developed. So from A to Z, there are a whole array of technologies available. I'm not going to talk about which one is the best, but if you're a beginner, for example, I know some of you are researchers, the area you should focus on is especially in Python, use of Jupyter Notebook, and also version controlling. So with that, actually, you can do a lot, right? And that's what I have been doing for some time now, with the industry introducing some of these technologies, especially the problem right now is, as data miners or data scientists, sometimes we don't understand the domain. So what we now focusing on, we convert domain expert to data scientist, right? That is the trend that you can see in the industry as well. So not that you give your problem to somebody else because you understand the problem. So you acquire the necessary skills, you to explore the data, right? Okay, so machine learning, there are a lot of, algorithms used, especially when it comes to time series data. ARIMA models, the vector auto-regression methods are quite popular. And when it comes to classification or traditional machine learning, we call it the random forest methods like ensemble models, which uses ensemble of trees, are quite popular. Then supported machines and XGBoost. These are some of the algorithms for those who are interested. I'm actually listing them. Right. The next one, before we go to the next set, I would like to briefly go through with big data, because I've seen now there's a lot of interest in, especially in logistics and transportation area, on big data analytics. And I can understand why, because I already showed you like the data coming from multiple sources. So when data come in multiple sources, multiple formats, yes, it's not very simple. So big data analytics actually focus on, especially when you have the volume size, right? So we know some of the models work best when you have a large number of data. So we are getting a lot of data. Of course, volume is one of the characteristics that you will get in big data. Then the second one is a velocity, the speed the data is created. Now, for example, real-time streaming data is huge. Like if you, for example, if you try to, extract pattern from the social media data, for a 1 minute, you will get the hundreds of gigabyte of data in the social media platforms, which is huge. And traditional computers or traditional computer technologies cannot handle that. Then we will talk about the variety, because that I think very relevant to transportation and logistics area. Data coming from multiple sources, coming from social media, coming from research data, surveys, industry report. You are getting location data, you are getting images, you get supply chain data. You can see a lot of variety of data sources coming in. So we need the technology, developed to handle all these various different types of data. And finally is veracity, that means the credibility of the source, or the suitability of data. So these 4 V's is very important when it comes to big data technologies. And I see that's why this big data analytics is quite popular. So when I say this, different types of data, let me briefly just to give you a. So normally in databases, we have tabular data, or Excel sheet, for example. We have nice tabular data form like this. So we can say they are well structured, and this is easy. But when you have some other semi-structured format like HTML or like JSON, like XML, where there are different data formats available, they are semi-structured data. And interestingly, if you look at social media data, they are unstructured. So nowadays, we are interested in extracting information from all these different types of data, which is we have to work with big data technologies. So the challenges in big data especially is the data growth. So that is the topmost challenge. The rate of data generated is very difficult organizations to handle, right? So that is the topmost issue when it comes to challenges in big data. But if you look at the technology array, so in big data, especially Hadoop is quite popular. And also the related tool set comes here, starting from storing data and the data will be stored in multiple places. We call clusters. So we can put data in different places. And then there are some other technologies actually built there to handle, this distributed fashion of analytics, like, mode for machine learning. So you can see again, this set of technologies are used to handle, big data analysis. To give it a simple terms, in big data, what we are going to do is we are going to distribute the data. We are going to distribute the processing as well, so that we will make it more efficient, right? Especially when you have a large number of data, right? Last one that I want to talk about, the deep neural networks. I told you, especially if you're working with the images and also the video data, especially quite popular, the deep neural network. In traditional neural network, we don't talk about a lot of hidden layers or the layers in the middle, right? Simply, you can think of this as kind of inputs and then the output. And within that, we create a set of layers to improve the accuracy, right? So in here, so there are quite popular, deep learning algorithms are in use in, especially in transportation. The traditional, starting from traditional neural networks, we will have deep neural networks with feed-forward networks, recurrent networks, long-term short memory networks, gated recurrent unit, convolution neural networks. So these are like some of the algorithms you can find in the literature. Right, now since I talk about the literature, so let's briefly talk about, what, traditional research journals available. So I have seen like many related transportation journals were there. But then again, the Journal of Big Data Analytics Transportation was quite fascinating. It started around like 2019, and they were publishing, directly big data analytics in transportation, which I think those who are interested in, you can have a look at it. And they were talking about how new analytics technologies is used, particularly in transportation area. But then I have actually searched on different terms. I told you now we have seen different technical terms we have used. And I have searched these different, search items in these journals, and the numbers are representing this. So what I notice is machine learning is quite popular in all these journals that I have seen. Especially, I have seen a lot of articles written in Transportation Research Party Emerging Technologies, especially machine learning. I found around like 550 articles on use of machine learning, especially in transportation, right? Similar to that, I will also see an interest in data analytics, data science, and big data, right? You can see the numbers here. This is only the top, transportation journals I have found. The first 4 journals I have selected, and these are the numbers given with the articles with these technologies are in use. Right, I think we almost complete the, here are like some of the references I have actually used to create the presentation. And I hope that during the presentation, I give you an idea about what data analytics is and different terminologies we have used, how they interrelated each other, plus how data analytics is used in transportation and logistics. Having said that, that's all from my side. Thank you very much.
Thank you, Mr. Deegalla. That was an intriguing presentation. So, ladies and gentlemen, it's time for Q&A session. So if you have any questions, please raise your hands. Once again, it's time for Q&A sessions. So if you have any questions, you may raise your hands. Is there any question for Mr. Deegalla? Oh, yes, I see one raised hand.
Hey, this is Jana. Can I make a question? Hello, can you hear me?
Yes, excuse me.
Yeah, we can hear you.
Yes.
Hey, Dialog.
Yeah.
This is Jana. How are you, mate? How are you, mate?
How are you, Jana?
So nice to hear from you after a long time.
Nice to hear you.
Yeah. I just want to ask a question. Anyway, we'll talk about another thing later. So, how the big data and the technology going to work, and how are you going to differentiate the technology for the developing country and developed countries? There's any identification or sectorization you can do for that? Have you done any analysis on that?
Yes, in our
So, when I
case,
say we have a developing country, we have poor infrastructure. There's no infrastructure to develop. But when you talk about development, we have infrastructure, communication, everything has been done. So now, how we can differentiate this between these two countries to make the system to work efficiently?
yes, one of the things now is we are actually moving from traditional on-premise, having infrastructure to we will have cloud-based systems. So most of the technologies, if you can see, they have their own cloud-based infrastructure for you to develop. And the model that they have used is normally for depend on how you use your system, how we use their system. The financial model is so that you will pay for what you use. So traditionally we had an issue. Now, for example, traditionally we have difficulties procuring this equipment, saving setup, and we also have difficulties in having expertise to this. So now what we see here is now we are getting access to these cloud-based systems for free, or with a very minimal amount of the cost that you have to bear for your analysis, especially for research. Nowadays we can easily use cloud-based system rather than you are going to set up your infrastructure.
Yeah, thank you.
Okay. So I see someone else has raised their hands.
Yeah, can I ask one question?
Yes, please go
Yeah,
ahead.
first of all, thank you so much, Deegalla, for informative presentation. One thing I want to ask, because you told like these are all like time series or time dependent variables you collect this traffic data. So when you train the data, how far you can predict these things? That is one question. Another one is like this transportation. When you come to transportation or the traffic, when you come to the transportation, it is dependent on people's choices.
Yes.
So whether these choices can be incorporated in your machine learning algorithms. So those are the two techniques. And I saw logistic expertise there in the audience, Dr. Siva. So he will ask some questions on logistics. So I am asking on this transportation side.
Yeah, as I told you in the beginning, I'm not an expert in transportation logistics, particularly that area, but what I have seen there is like these people choices, they are automatically recorded right now. For example, if you're using Google Maps, at the end of the month, you are getting the places that you have visited. I don't know if you open up at that option, usually you get an email saying that, okay, what are the places that you have actually visited? That means from the other side, they are collecting what choices we are making. That's why I said, like the example that I have showed you on Korea. So what they were doing, actually, they were suggesting, different routes based on, for example, safety. So if the person is concerned in the safety, they can choose that. And that choice is recorded in the system. And that can be later you can use to make, predictions.
Yeah, thank you. What about the time series? When you use the time series, so
yes,
for example, if you use like 2 years data, so how far you can predict? Is it like 1 week, 2 weeks? Or
it depends actually. I think it's it's a domain dependent question. But then the traditionally, so it depends on what we call the window that we will actually select, right? So whenever you want to make more reliable predictions, then you increase the size of this window. So not related to this one, but let me give you an example for, let's say, in financial markets. It's crucial, right? You never know which side you are going on. So traditionally, when we want to have the confidence to increase, so you can look at the moving averages. Let's say 200 days versus 20 days. And then again, you can make it a boundary and see so what changes will happen during, you know, this moving average changes, like standard deviation of, let's say, 20 days. So within that, you can make the prediction, and that is, as I told you, is problem domain. So you have to find and see it's data dependent, I guess, the answer for that question.
Okay, thank you so much. Thank you so much.
But if you look at the, I have not worked with the, the transportation data much, except I work with one, with a set of students, we work on predicting, road safety based on the social media data, where we have not collected any of the data from the maps. But what we have used is we have used Twitter, data to, collect accident related information. With that, it has the location data. We have populated, okay, what are the routes that are not safer compared to the, other routes.
No, that's interesting. Thanks anyway. Thank you very much for your presentation again.
Okay, there's another question on whether there are any company using intelligent transportation in Sri Lanka. So I'm not really an expert. Maybe Dr. Jayalak, maybe you can.
Thank you, Mr. Sampath Deegalla, for the interesting presentation. Yes, I think ITS is used in few companies in Sri Lanka. I do not have exact information. Definitely, there was one famous ice cream company who used ITS in different ways to decide their route and to locate their warehouses, etc. So I have to exactly find. I wonder whether Dr. Siva has raised his hand. Dr. Siva has information exactly what companies use. But definitely, ITS should be in practice in Sri Lanka in different companies.
Thank you. I think, yes, there are certain companies, they are using, I don't know whether I can say some names, but then, yes, different techniques has been used, and many companies are more and more wanted to use these techniques in their optimizations, and even real-time optimizing their route and incidents management and so on. Yeah, so interesting. Thank you very much, first of all, Deegalla, for your interesting presentation. The connecting the technology domain, that is the computer science domain, with the transport and logistics, which is growing overlap discipline in this recent era. My question is like, still we are struggling to get the accuracy using this machine learning and deep learning, because when it comes to real world data collection, it can be transportation or it can be logistics, but if we look at the, when we put the enumerators on the manual counting, they could be able to detect even partial of the vehicle. They can detect whether it is a lorry or bus or truck or container or something. But then when it comes to images, we still have problem because the portion, so let's say a quarter portion or maybe percentage of the image is having a truck, then the learning and the prediction is still struggling in particularly in our cities. Maybe the same scenario may be common for this Asian countries traffic pattern. But then this JOLO and other kind of machine learning models are working pretty well because the lane discipline and the gap they maintain between the vehicle and so on. So probably because of the very less gap we maintain, we seriously having some issue in getting a better accuracy. Have you come across anything, and or maybe are there any special learning processes taking place in Sri Lanka?
Yeah, just to add, YOLO type machine learning techniques that we have used, like we recently worked with one of our graduate students on overlapping objects in a shopping cart, which is kind of very similar scenario comes when you have a traffic jam. So I think things were improving. I think you have witnessed from YOLO version 1 to now the current version is version 5, which
Yes.
actually drastically improved in this sense. So by together comparing multiple algorithms, the people actually working on towards, as you said, it's not 100% accurate. But then again, we can foresee in the future, in coming 5 to 10 years time, we'll get more accurate information on this regard. So that's the belief, and that's what we have witnessed. And I think in Sri Lankan market also, we need to think about these instead of traditional data analytics, we should move on the latest technologies to improve decision making process in our country as well.
Thank you.
And just to add, Isuru asked like whether there are any converting industrial experts to data scientists. Actually, we are doing a couple of programs in different levels. So if you are interested, maybe you can write to me and we can discuss some of these helping out programs for converting industry experts to data scientists.
Sure, thank you.
I see another question raised. I see another hand raised.
Thank you.
Please go ahead.
Thank you, Sampath, for the nice presentation. I just wanted to know, like Google Map or a Google related data, is there any other free data available from this transport and logistic area? You came across any places or any websites or anywhere we can collect free data?
One of the things is here.com. I think I put the link there in the presentation. Anyway, I will share my presentation with you.
Yeah.
The partially free. If you're a researcher, actually data is free. If it is a company, I think you have to pay some small fee to access this traffic data for I showed you like about research work on 45 countries, and there they have used the here traffic data, where they will open data collection, and that is actually free for academic use.
Okay.
And there are others website I didn't check, so you may check. I have listed several others as well, along with Google.
Thank you. Thank you very much.